So, physicists, I want you to stay focused with me on the front of your sheet. Some of you got tons of data. Some of you may not have gotten all of the data. And regardless of where you were at, we are all going to do the analysis now. Okay? So if you didn't get the data, I'll put some data up for you in just a couple of minutes. But what I want you to focus on right now is this equation here. Okay? Our goal is to determine the focal length of a lens based on the values that we found for the object distance and the image distance. So I'm actually going to look at this little picture down here real quick first. So the object distance is the distance from the light bulb to the lens. The image distance is the distance from the lens to the screen. Okay? So on Friday, you saw the little, a picture, an image of the filament on the screen. Do you remember that? It was kind of cool. It like actually showed up. It was like a picture of this thing that appeared here. It's amazing. What did you notice about the image of the filament? What did you notice when you were taking data besides the distances? Was the filament right side up all the time? No. What was it? It's inverted. It was flipped over. So fun fact, I just want to share this with you. I think I shared this with a couple of groups, but I don't think I shared it with everyone, is that your eyes have lenses in them, right? And your eyes bend the light that comes in so that you can collect all of that light back on what they call the optical nerve, which is at the back of your eyeball. Okay? So literally this same thing is happening inside your eye all of the time. So light is coming from whatever it is that you're looking at, being focused by the lens so that you get an image on the back of your eye. Tell me about these images. What were they? They were all what?
Inverted.
They were all inverted. And in fact, this is just an amazing thing, an amazing feat of science in your brain. Your brain actually receives the image upside down. So everything that you're looking at, the actual light that gets to your optical nerve is inverted. And your brain is smart enough and clever enough to flip it back over. So I think that's kind of awesome and amazing, right? So that up is up and down is down. This is even more amazing. So you add more lenses, and more lenses do different things. So glasses, if you wear glasses or if you wear contacts, you're putting another lens on top of the lens that your eye has, and it helps to focus the image, okay? So you remember when you were moving the lens and it was a little bit out of focus? So if you have glasses or you have contacts, what's happening is that it's focusing either a little bit in front of or a little bit behind where that ocular nerve is, where that spot is that we're trying to get the image. And so your lenses, either in front of or on top of your eyeball lenses, adjust so that the image appears directly on that ocular nerve. It's pretty awesome. One more thing, and this is the part that I think is absolutely incredible. It's possible, it makes sense, and one can do it. Put lenses in front of your eyes that flip the image again. Okay? So you can get them to flip and flip. And so if you wear these glasses, that means that the image of what's coming in will be inverted and then inverted back so that it's the right way up. But your brain says, wait, that's upside down, right? Are you with me there? Because it's used to saying up is up and down is down. You wear these glasses and it looks like everything's flip-flopped, right? If you saw Mary Poppins Returns, we're talking like Topsy, right? Like it was flipped over, okay? This is the part that's incredible to me. If you wear those glasses for, I think it's like 3 hours, maybe not even, your brain is able to interpret that and it flips things the right side way again. So that up is up and down is down for you. It's that clever. Isn't that amazing? Then it's backwards, and then your brain, it takes a little while for it to like process and flip it back over. I think it's crazy amazing that your brain is that clever to be able to do that, to flip it back and forth, so that you know which way's up and which way's down, and you can actually walk and not feel like you're walking on the ceiling, for example. Yeah?
So if we wore them and then took them off,
yes, then it would be flipped again just for a little bit.
our regular vision would be flipped?
Yes. And then your brain would fix itself and then it would be okay again. It's all amazing. I don't have them, but I just read a story about them.
I thought that was just the
No.
The story that you had.
No, I don't. That would be amazing. No, I don't have any of those. But it sounds fun. I would love that. I just think it's amazing that your brain can do that. Like, that is crazy cool. All right. So anyway, that's my little story of like just how cool your brain is. That's about as close as I get to teaching you biology. So there you go. That's your biology lesson for the year, probably right there. Okay. All right. Now let's get back to physics. Yay. All right. So this is the equation that I told you kind of governs all of this stuff. I think I mentioned to you that you will not actually need to use this equation in any quiz or test situation at all, but I do want you to be like aware of it, which is why we're doing this today, okay? So there are three things on here. We've got the focal length, we've got the image distance, and the object distance. Which two of those three did you measure on Friday? Look at the back of your sheet. Thank you. I love it. The image distance and the object distance. Those are the two things you measured, right? So we could just graph image distance versus object distance, and that's going to give us some sort of weird, funky graph that I don't even know what it's going to look like. It's going to be really, really hard for us as high school math students and physics students to interpret to get the focal length. So we're going to use our knowledge of this stuff to make it easier. So here we go. What kind of graph do you all know and love the most that you can interpret the easiest of any graph that's out there? What type of graph?
Regular.
A regular. What do you mean regular?
With dots and the lines.
With dots and lines. Like really what I'm thinking about is a line. A graph that is a line looks like what? Looks like y equals what? Yeah. You guys know it so well you could talk about it in your sleep. Y equals mx plus b. We know this. We love it. We understand it. Y and x are the things that we measure. Okay? M is the slope and b is the y-intercept. Okay? So my goal for you in the next few minutes is to get this big, scary looking thing to look like that. Because if I can get it to look like that, then I can graph it and I can get stuff out of it. I can learn something from it. So y is one of the things that I measured. And x is one of the things that I measured. So you notice in this red equation that I've got one of them on one side and one of them on the other side. Is that what it looks like over here?
No.
If it doesn't, let's make it that way. Is that okay? Let's make it that way. How am I going to get it so that it looks like that?
Divide by y. Subtract.
Let's subtract one of them, shall we? Let's subtract one of them. I'm going to ask Amanda, which one do you want to move? Object distance. Does not matter. It's a good choice. I'm going to move the object distance. You do it too. So here we go. I'm going to say 1 over the focal length minus 1 over the image distance is equal to 1 over... Wait, did you say you wanted to move the object distance? I'm sorry. I totally did the wrong one. I had it in my head. I was even saying object, but I was thinking I'm going to keep it on this side. Sorry about that. Now I am following your wishes. The focal length minus 1 over DO is equal to 1 over DI. Are we okay with this? Focal length is what I'm just calling F because I'm lazy. Image distance is going to be DI. Object distance is going to be DO. Okay. So now we're looking closer. We got 1 on one side and everything else on the other side. There's some pluses and stuff going on. This is looking better, but I'm going to rewrite it one more time. Tell me if this is okay. I'm just trying to get it to look a little bit more like the other one. Actually, I'm going to write it over on the other side here. We're just going to keep going to the left, which is kind of funny. 1 over DI equals negative 1 over DO plus 1 over F. You see what I did there? I did a couple of little algebra moves without really saying anything out loud. So I just flipped it. So I put this stuff on this side. And then I just switched the order of these two. Because 2 plus 3 is the same as 3 plus 2, right? So the order of those things does not matter. This to me looks a lot better than, or a lot more like this. Does that make sense? Yeah? Quick question before we move on. Oh yeah, go for it.
This might be a silly question, but like,
No, you're
why
fine.
didn't you keep the way it is? Like
The pink way?
one? No.
This one.
Yeah.
It's not a silly question. It's a very good question. The reason that I didn't want to leave it like this is because I want one of the things that I measured to be by itself and the other one to be on the other side. Because let me show you why. Because in just a minute I'm going to ask you. I want to know what to put on the y-axis and what to put on the x-axis to give me a line. And looking at this, I have no clue. Does that make sense? Because I don't know what the y and the x is because I got this thing over here. And did we measure focal length? We didn't measure focal length. So I don't know what my values for this would be. Does that make a little more sense?
Yeah, it does.
Okay, thank you for asking that question. We are no silly questions is the mantra that we have. One really quick question before we move on to actually how to graph this, which is kind of what Kara was asking. Can I get rid of the 1 over stuff? Instead of writing 1 over focal length equals 1 over image distance plus 1 over object distance, could I just write focal length equals image distance plus object distance? Yeah? Let's double check. If I have 1 over 4 plus 1 over 4, what does 1/4 plus 1/4 equal? What is it? 1/2, right? Everybody good with that? I have a quarter of a pizza, you have a quarter of a pizza, together we eat a half a pizza? Yeah. Now my question for you is really saying then, come on, silly thing. Is 4 plus 4 2? It's not, right? So just to be very clear, we cannot just get rid of those 1 overs, right? There's a reason for it. I'm not going to go through it with you unless you really want to know. If you really want to know where this comes from, and I always say this and I feel like people think I'm just joking, but honestly, if you want to know where this comes from, let me know and I can show you exactly where it comes from. It's not that hard to figure out, but I just want you to be aware that the ones do matter. Okay, the 1 overs do matter. Okay, so let's take a look at these two. I've got this one here that I know, love, and understand, and I've got this one here that's new and funny and different. Okay? If I'm trying to figure out what I'm going to graph, I'm going to go ahead and draw my little graph down here. What is going to be on my y-axis? The image distance? Is it going to be just plain old di? 1 over di. It's got to be 1 over. The 1 over does matter. And it seems a little weird, but it really does matter. So this is going to be 1 over di. What's going to be on my x-axis? Look at the similarities between these two yellow boxes, friends. Here's my y. What's my x? 1 over the object distance. 1 over the object distance, yeah. So that's what I'm going to graph, is 1 over do and 1 over di. Now, this is where some really interesting thinking happens. What is my slope going to be? What's my slope going to be? Where does the slope live in the top equation? It's m, right? and it's just in front of the x. So it's going to live right in front of the x here. So what is my slope going to be? -1. Yeah, it's as if you all knew that and you just didn't want to say it or something. Is that true? You kind of had it, maybe it was down in your gut and you're like, maybe that's what it is, but I'm not positive, Miss K. Yeah, it totally is. My slope is going to be -1. So it's going to look something like this. Oops, come here. Something like that. And we don't often play with the y-intercept, but what does my y-intercept represent here? What's that? Yeah, exactly. It's 1 over the focal length. You got it. Let's see if this will work with my, that's kind of scary looking, sorry. Oh, that's really icky looking. Ugh, can I get rid of that easily? Let's see, there we go. Maybe I'll just circle it with some other color. I just don't have any more pretty highlighters. We'll just go like this. There we go. Okay. So that y-intercept is going to be 1 over the focal length. How are we doing? Okay. So your task in the next little bit here is to take your data of DO and DI. You're going to put it into Google Sheets. Remember, you're going to make Google Sheets work for you, right? Don't do too much work. You've got lists of DO and DI. You can let it calculate this. And if you don't remember how, ask me. I'll help you. Okay? I will tell you, we may have noticed on Friday that some of the data from Lens A was a little bit not great. Okay? And last period, we figured out that Lens A is really not great at all. So we are only going to graph the data from Lens B. I think most of you collected data from Lens B, but if you did not, I will put some up on the board so you can just copy it down. Okay, I'll do that in just a moment. But right now, get out your Chromebook. I want to be very clear. Every person needs to make their own Google Sheets. So if you and your buddy did it together, like took the data together, that's awesome. And if you want to sit next to each other and cheer each other on, that's awesome. But I don't want you to share a Google Sheets between the two of you because I want every single person to have this experience. Okay? Go ahead and get started. I'll put some data up on the board in just a moment. Good shape and just rocking it, then just keep going. But if you need a little help, so just to be really clear about what we're doing here, in order to graph this, we need 1/overs, right? If we just graph this, it's not going to do anything. Shh. If you're in good shape, please be quiet. You can keep working, but please be quiet so everybody else can hear. So I'm going to do 1 over DO. I'm just typing that in for my label so that I don't forget what this is. And in this box, everybody's eyes up here if you need to know, just so I don't have to do this a bunch of times. I'm going to type in equals 1 over. I'm going to click on this one because that's my DO. If I hit enter, it's going to do the calculation for me right there. Boom. In order to get it to do all of them, I do not have to type that in multiple times. I'm just going to go way over to this bottom right-hand corner, click, and drag down. Oops, I missed one. Click and drag down. Okay? These are the numbers that we're going to graph. So you're going to do the same thing for 1 over DI. Okay? And then we'll graph. I'm going to let you work on that for a minute, and then I will come back to show you how to graph. So now that you've got your list of DIs and DOs, now we just need to graph it. We need to put it all together. So sometimes Google Sheets thinks it's a little smarter than you. Sometimes it's really, really dumb. And it seems kind of like a crapshoot. You don't really know. Can I have everybody's eyes up here if you do not yet have a graph? So that I know that you're watching this and you don't have to watch it over and over. I don't have to explain it over and over again. I'm looking out for myself here, going to be honest. I'm going to go to Insert, Chart. Now, I want you to just watch it because I don't want to have to pause every 5 seconds. Okay? So I'm going to go to Insert, Chart, and then it thinks it's clever and it says, oh, you want a bar chart? And I say, no, chart. What are you talking about? No, thank you. So I'm going to say, no, thank you. Let's go up to chart type and say, what kind of chart do I want?
A line chart.
I do not want a line chart. Never, ever, ever.
Scatter.
Scattered. Physics and science in general always ask for scatter plots. So you got this thing and it's just like a bunch of dots and you're like, great, that means nothing to me either. So now we need to tell it what we want. So I'm going to take this graph and I'm going to move it so that it's out of my way. I'm going to scroll up so that I can tell it what I want on my x-axis. So do you see where this says x-axis? I'm going to click here, say, this is the stuff I want in my x-axis. I don't remember. Amanda, what did we decide you wanted on your x-axis? Object distance. So I'm going to highlight just the object distance. That is all I want on my x-axis is the object distance, or the 1 over object distance, I should say. And then, so x-axis is here, and then series is my y-axis. That's what series means. So I'm going to remove this one. I'm going to make sure by saying edit, I want to make sure that I have the right stuff here. My mouse is being a little crabby. Stop, please. Let me try this one more time. Just try it with my regular mouse here. And now if I look at my graph, let's see what happens. Come on, thing. Oops. I get a graph that's got a negative slope, right? A negative slope. We can figure out what the negative slope is if we go to Customize, Series, Trend Line, and then scroll down a little bit further, Label, Use Equation. Okay. It's not quite -1. It's about half of that. But it's the right idea. I'm not going to sweat it a whole lot. This is about the experience, not the actual data. Are you with me there? It's about the experience, not the actual data. So I'm going to do this. You are going to put some labels on things. The one thing that I want to point out and tell you here, so I'm going to jump back over here, okay, is that the thing that I really want to know is my y-intercept. And your goal, the primary task here, is to compare this thing to the known value. The known value for lens B, the focal length is 15 centimeters. Okay? So you need to take your data, and I'm not going to tell you how because this is the thinking and the processing and the physics that I want you to understand. Doesn't mean it won't help you if you need help, but I'm not going to tell you how to do it. This is the focal length that you're shooting for. Okay? I'm going to give you about 4 more minutes to get wherever you need to go. This lab write-up, not with the second lens because we only are doing one, okay, will be due on Thursday. You'll need to share your Google Sheets with me so that I have it by Thursday. Actually, I'm gonna put it on Canvas so that you can just submit it there. It'll be easier for me. But I will put that up so you can do it. I don't want you to stress about it, but I want you to know that that's when it's going to be due. Okay? So I'm going to give you just a couple minutes to finish up wherever you're at, and then we're going to regroup and do a little bit of note-taking before the end of the period. Okay? Right there.